Welcome to lesson 3.2, and today's lesson is all going to be about quadratic relations in standard form. And what we mean by standard form is our function f of x is going to be equal to ax squared plus bx plus c. There's a couple interesting things that we can identify in the standard form. First off, the constant c, that's going to be our y-intercept. So that's going to be where the parabola crosses the y-axis. Another thing that we can see here is in front of the x squared is a, and if a is positive, our parabola opens up, which means it looks like that u, big U. If a is negative, our parabola opens down, and so it's going to look like an upside down U. And when A is positive and it opens up, our vertex is actually going to be a minimum point. And when A is negative, our parabola opens down, our vertex is going to be our maximum point. So let's take a look at this here. So we're going to start off. Sketch the graph of y equals 2x squared minus 6 and state its key features. Well, graphing you can always do. All you need to do is fill out your table of values. I always choose points on both sides of 0. I like dealing with small numbers when I sub them into the equation. Just makes our answers normally a little smaller. So when I sub minus 2 in for x, y ends up being positive 2. When I sub in minus 1 for x, y is minus 4. 0 for x, y becomes minus 6. Positive 1, it's minus 4. And positive 2, it's 2. So, instead of sketching this graph, what I'm actually going to do is I'm going to use decimals. So y equals 2x squared minus 6. Let's go to decimals. Y equals 2x. Now, in order to do a square, we have to put in the little hat sign. It's Shift F6. And when you do that, decimals automatically recognizes that you're putting in an exponent. So you put that exponent in, and then you can just move your cursor one to the right, and it'll go back down into regular form. So let's just double check that equation. Y equals 2x squared minus 6. So now I need to put in minus 6. All right. And let's just, we're going to just come down here. Perfect. So we can see the parabola opens up, and we're actually going to be able to go through. We're going to flip back and forth, and we're going to just examine the properties here. All right. So we can see 2 minus 4 minus 6 minus 4 and 2. Let's just verify that we did that right. Minus 6, and then, of course, we've got our minus 4, and then we've got our positive 2. And the same thing on the other side. We start at minus 6, minus 4, and positive 2. So every time we go over 1, we're going up a few. And I'll talk about that really briefly. It's going to be the step pattern. But right before we do the step pattern, let's just look at some key features of the quadratic relation. So this quadratic relation opens up. It looks like a U. Well, we've seen that. Now, if we want to figure out what our x-intercepts are, this is when y equals 0. We could sub in y equals 0 and then solve for x in this equation. Or we can use decimals. Decimals is really good at this type of stuff. And you can see, as soon as I click on my parabola, it identifies some key points. My x-intercepts, if I look, Not a very pretty number. Negative 1.732, 0, and over here, positive 1.732 and 0. So Desmos really good for that. So my x-intercepts are negative 1. I believe it was 732. Let me double check that. Yes, negative 1.732, comma 0. Y is always going to be 0 at the x-intercept because that's where it crosses the x-axis. And positive 1.732 and 0. Now, the y-intercepts are, well, we're only going to have one y-intercept in this one, and we can get that. Remember, our standard form is y equals ax squared plus bx plus c. Well, we don't have a bx, but we do have a c, and we know our c is always our y-intercept. In this case, it's negative 6. That's one of the handy things about having your quadratic relation in standard form. So when x is 0, y is going to be negative 6. We can verify that just going back to Desmos. Oh, yeah, right there, we're crossing the y-axis, 0 minus 6. That's also our vertex in this one. So the vertex, that's our minimum point. And in this case, it is 0, 6. And I'm just going to put minimum. And axis of symmetry, if you remember, that's that vertical line that goes right through our vertex. And so what we want to do here is we always just state it as x equals a certain number. Because it's a vertical line, x is always a constant there. And in this case, it's at x equals 0. If you ever want to know what your axis of symmetry is for a parabola, go to your vertex, your x coordinate, that is your axis of symmetry. So in this case, our axis of symmetry is 0. Now let's just go fill that out. All right, the vertex, axis of symmetry is x equals 0. And we want to just see this. Every time we go over one horizontally, we go up not by a standard amount. So when we go over 1, so that's over 1, we go from negative 6 to negative 4, so we go up 2. So let's just write that down. Negative. Or sorry, we go up 2. So we went up, we went across 1. We went up 2 units. What happens when we go across 1 again? 1. And we're going to go up 6 whole units. So we're just going to put that in there, and we're just going to stop right there. This will become important very, very shortly as we talk about the step pattern. All right, so that's our properties of this quadratic relation. Perfect. So let's go to our next one here, and just gonna fill this out here. So minus 2. Oops. When x is minus 2 squared is 4. That's going to be times negative 1, so negative 4. Minus 2 times minus 2 is positive 4. So minus 4 plus 4 is 0, minus 2. So we have minus 2. If we sub minus 1 in for x, minus 1 squared is 1, times minus 1 is minus 1. Minus 2 times minus 1 is positive 2. So 2 minus 1 is 1, and minus 2 is going to be minus 1. When we sub in 0 for x, y is going to be negative 2. When we sub in positive 1, we're going to have negative 1 minus 2, so that's minus 3. Minus 2 again is going to be minus 5. And one more. 2 squared is 4 times negative 1 is negative 4. Minus 2 times 2 is 4. So minus 4 is minus 8. Minus 2 again is going to be minus 10. And once again, don't worry, you will get some opportunities in the next lesson to graph. But for right now, let's use decimals again. So y equals minus x squared minus x. Remember, let's just use that exponent. Minus x squared minus 2x minus 2. Interesting thing here. But we can see we're in standard form, ax squared plus bx plus c. A is negative, so that tells us our parabola is going to open downwards. And we can see visually here that it does. Let's just slide this over a little bit. And our y-intercept is minus 2. So where it crosses the y-axis is at 0, minus 2. So 0 minus 2. Perfect. We verified it. Now, interesting thing in this one, let's go through the properties and we'll see some interesting stuff happen. So in this case, how does the quadratic relation open? It opens down. All right, what are x-axis or x-intercepts? So remember, our x-intercepts are where the parabola crosses the x-axis. So let's take a look at decimals again. Well, here's our x-axis up here, and our parabola never crosses the x-axis. So very important here, x-intercepts are none. Y-intercept, there's only one, is, we already know that. We can get that right from our standard equation. 0 minus 2. The vertex, let's go back here and figure out what our vertex is. Minus 1 minus 1. And since the parabola opens downward, this is our maximum point. It never gets any higher than minus 1 minus 1. So let's go back. Our vertex is at the point minus 1 minus 1. And that's going to be a maximum value. So let's just change this. We're not going up. This time we're going down. So every time we go over 1 horizontally, we go, and let's do the step count here again. So we go, all right, we go over 1, we go down 1. All right, so we went down 1. We can actually make that, it's a negative 1. So we're going down negative 1. Now we're going to go over, and we're just going to check that again. We're going to go over one more time, and how much do we go down? Oh, what's that point? Oh, minus 5. We were at minus 2, so we've dropped down another 3 units here. And don't worry if you don't have this figured out yet, because we will be talking about it again. So, all right, now what happens if we go over one more? Let's do one more. And that point, oh wow, it's down at 2 and, whoops, there we are. 2 and minus 10. Well, we were at 1 and minus 5. Now we're at 2 and minus 10. So we dropped another 5. Whoa, what happened there? Let's go back here. Minus 5. All right, so we went 1, then we went over again. We dropped down 3. Then we went over again. We dropped down another 5. Perfect. So we're starting to see a little bit of this thing called the step pattern. We're going to look at it a little bit more in depth in the next lesson. Let's finish off this lesson. And we're just going to go back to what we did in lesson 3.1 for a second. So recall that the first differences in a linear relation are constant, and a quadratic relation has a constant second differences. So linear relations, first differences are constant. Quadratic relations, our second differences are constant. So here we've got a linear relation, y equals 2x plus 3. I just pick some points to sub in for x. So when x is minus 2, 2 times minus 2 is minus 4 plus 3. Oh, minus 1. Sub in minus 1. 2 times minus 1 is minus 2 plus 3 is positive 1. Sub in 0, y is 3, and then 5 and 7. Um, Now let's do our first differences. I've already filled it out here. This should be review from lesson 3.1, so you should be good with this by now. But if you ever have any questions, as always, feel free to let me know and I'll help you out. Let's just go through this. To find our first differences, we're going to take y and we're going to subtract the previous y value. We want to find out what happens when x changes 1 unit. What happens to y? What's the change in y? So in this case, 1 minus minus 1, that's the same thing as 1 plus 1, so that's 2. 3 minus 1 is 2, 5 minus 3 is 2, and 7 minus 5 is 2. So our first differences are the same. That tells us it's a linear relation. Now let's look over at this one. In this one, we've got a quadratic relation, y equals x squared minus 2x plus 3. So when we sub in minus 2 for x, well, let's do it. Minus 2 squared, minus 2 times minus 2 is 4. So it's positive 4. Minus 2 times minus 2, once again, positive 4. And then plus 3. So 4 plus 4 is 8, plus 3, 11. And we can sub in other values, but I've already done it for you. So those are our y values. Now, when we do our first differences, 6 minus 11 is minus 5. 3 minus 6 is minus 3. 2 minus 3 is minus 1. And 3 minus 2 is positive 1. So we can see, oh, it looks like we're increasing by 2 each time. We're going to verify that with our second differences. So minus 3 minus minus 5, that's the same thing as minus 3 plus 5. That'll be 2. Minus 1 minus minus 3, once again, will be 2. And 1 minus minus 1, once again, that'll be 2. All right. So now that we've got that fresh in our minds, let's take a look here. We want to classify the relations below as linear, quadratic, or neither. And one thing we'll notice, is when we look at these, there's no equations. No equations for us to go off of. So what we're going to do is we're going to take a look at our first differences and our second differences. If our first difference is the same number, we have a linear relation. If our second difference is the same, is constant, then we have a quadratic relation. And if neither our first or second differences are constant, then we don't have either a linear or a quadratic relation. So if we take a look here, oh, let's see, our first differences, 9, 15, 21, 27, definitely not the same. They're not constant. We go to our second differences. Our second differences are all 6, so they are constant. So this one here is a quadratic relation. All right. What about this one over here? Well, if I take a look at the first differences, 7, 19, 37, and 61, definitely not a constant number, so it's not a linear relation. Our second differences aren't constant either, so it's not a quadratic relation either. So in this case, we have to classify the relation below as linear, quadratic, or neither. And in this case, it is neither. All right. That's lesson 3.2. I hope you enjoyed that. Join me for lesson 3.3 when we talk about quadratic relations in the vertex form. As always, if you have any questions, feel free to join me during live office hours or feel free to email me at any time and I'll get back to you as soon as I can. Take care.